So let me introduce our last speaker. We say here we leave the best for last, okay? So we have Dr. Chunping Yang. I don't know how well I did on that, but he is a professor of environmental science and engineering at Hunan. He has his PhD from University of Cincinnati in Ohio. So that's great. And actually, this is interesting. He's a registered professional engineer in both China and USA. So I think that's unusual. So wanted to point that out. He's going to talk to us about biofiltration for VOC removal. Please go ahead. Welcome, Dr. Yang.
Okay. Thank you. Thank you all. I'm very happy to have the honor to speak here. Today, my topic will be biofiltration for VOC removal from innovations of biofilters to removal mechanism. First of all, I will talk about what I are doing in my group. And there are several projects are undergoing in my group. First, on the topic of biofiltration, we have a grant supported by the Natural Science Foundation of China. The title is Mechanism and Measures for Enhanced Removal of Hydrophobic VOCs in Gas Biofilters with presence of surfactant. And on the biological nutrient removal, we have also a grant by the NSFC. The title is Response of Microorganisms to Combined Stimulations of Surfactant and Salts in Biological Nutrient Removal. And on groundwater treatment, we have a contract called Biolalo-Technologies for pollutant removal from groundwater, with atrazine removal as the case study. It was supported by the Ministry of Science and Technology of China. In this project, also have two teams. One team in China side, led by me, and the other team is Eastern team in the Eastern Institute of Technology. And the fourth topic is compost of swing waste, co-digestion of swing waste and rest straws under various conditions, performance, mechanism, and engineered demonstration. And on swing wastewater treatment, supported by the Hunan province government. On the responses of not this one, photobiological conversion of swing wastewater. And on industrial wastewater treatment. In this topic, we cooperation with the local government and companies for various different treatment of wastewater. Now, I will back to the topic of today very briefly. First, I will give an introduction. Control of volatile organic compound and odor emissions from industry and municipal facilities has become a major environmental concern. Methods to control VOC and odor emissions have physical chemical control processes and biological control processes. This is the schematic of biotriggering filters. And the advantages of biofiltration include it is cost-effective, it's environmentally friendly, and the process is simple. However, they have some shortcomings of traditional biofilters. And to overcome these shortcomings, we develop several new biofilters. One is called the rotating drum biofilters. This is the schematic of the rotating drum biofilters. And we have developed several different types of rotating drum biofilters. This is the photo of the biofilters we designed. This design in the Cincinnati. This is the performance of the, I will not detail the performance here. Advantages of rotating drum biofilters. There are several. This is the 4 major advantages. It distributed the nutrient VOC loading, etc. more evenly, and long durations, and also more stable removal efficiency, and it can avoid medium degradation. However, there are also potential problems for these biofilters, such as mechanical requirement and more maintenance fees. So we develop tubular biofilters. In tubular biofilters, we remove moving parts, and it can overcome this problems. This is the advantages of tubular biofilters. So the performance of the tubular biofilters. And this is multi-tubular biofilters. For tubular this also we filed patents in US. On the biomass accumulation patterns and the classification of biofiltration. When we when studying the rotating drum biofilters, we find different biomass distribution patterns. We classify them as in-depth biofiltration, shallow biofiltration, and surface biofiltration. On this discovery, we proposed mechanism-based procedures for biofilter design and operations. This is the multi-tubular biofilters. Also, we do modeling, mathematical modeling of biofiltration. This is the rotating drum biofilters. We develop the biofiltration models and solve this modeling. Here, we calibrate the model, and the model result and the experimental result is very good, pretty good. On the enhanced removal of hydrophobic VOCs, we have to also do some investigations. And finally, on the perspective on biofiltration, such as the monitoring and analysis method of microbial communities and biofilms, and the dynamic simulations of biofiltrations, and the simulations simultaneous removal of multiple components, and the mechanism of biofiltration process, and more cost-effective biofilters. Thank you. Thank you.
Very good. Okay, I'll open it up now for questions. First, we'll start with Dr. Young, and then any other questions or conversation we want to have. So, any thoughts, questions? So, most of your industrial treatment in China, do you have industrial pre-treatment before it goes to wastewater treatment plant, or does it discharge directly from industrial process to the wastewater treatment plant?
It depends.
Okay.
If the company located in industrial zones, then there may be the company make a pre-treatment and then discharge in the wastewater treatment plant. Otherwise, they have to meet the other strict requirement.
Okay. Comment? Yeah? So,
I think for the industrial wastewater, so it's not about
direct discharge. Yeah.
You have to,
Yeah. So you pre-treat and then you go to, okay. And is the pre-treatment relatively sophisticated for industrial process?
depends.
Yeah.
That's a requirement, but actually, some cases, they may not be getting pre-treatment, or even though
Yeah.
design has that procedures, but it may not be, that's the problem in China, but the government tries to enforce it.
Mm-hmm. Yeah, it's definitely a problem when you've got all these different industrial waste coming into a wastewater treatment plant to get them to function properly and to discharge the quality of water that you want to come. Did you have a comment or?
No, I
Yeah.
thinking about this aspect of it. Very challenging to control a wastewater treatment facility when you don't know what. is coming in
Exactly.
in a particular period of time.
Yeah.
Change
Right.
processes quickly.
Yep. And that's how we've dealt with it in U.S. is basically with pre-treatment standards and reporting, so that the systems are designed to handle the industrial. Yeah, it's a very difficult problem. I wonder in China, you look at the smaller cities where you have basically unregulated wastewater discharge. In some of these smaller ones, you spoke about this a little bit. Is there any thought of jumping all the way to some new revolutionary technology around discharge, or are we just going to retrofit to 20th century wastewater technology?
For the rural area, Chinese government encourage and they invest to develop a small decentralized system.
Okay, so decentralized system, but still typical treat and discharge into surface water. It almost seems like the assimilative capacity of the surface waters has been reached, and we need to we need a disruptive technology instead of 20th century wastewater technology. It looks like. Yeah. Yeah, good. Other comments or thoughts? Any of the speakers? Yes, George, go ahead.
For Dr. Shi, for your advanced adsorbents, are those commercially available, or do you specifically make those up just for your tests in
Right.
hopes that they will become commercially available?
I think right now, just, I synthesize the compound in
Make
the
it yourself?
by myself, but the final goals I hope can be get into the application, real application.
So if it works, then
Yeah.
you'll make it.
I found the industrial patterns, maybe make available, large scales. I already have some of the patterns, Chinese pattern.
But right now it's bench scale technology, and so the question, are they starting to be implemented in China? Yeah, so it seems like a lot of the approach really is towards treat and technology-based solutions. And in U.S. we've kind of been through that cycle, and now we still have many water quality problems. And a lot of the problems, Stephen, they're really more in your area, which is the watershed, right? I mean, so we've dealt with wastewater treatment, not completely, but largely, but we still have nutrient problems. We have, algae. We have E. coli. And it's because of I don't know if you have a comment, Stephen, but it's really about dealing with the watershed now at this point.
Well, I think China is just such a different scale issue. It's still a watershed-based problem.
Yeah.
But I think the way to look forward is a hybrid of some in situ technologies, but then handling the volumes
Yeah.
and then understanding how these systems respond. So we're lucky in this part of the U.S. where things aren't as messed up as they are back east.
Right. We still have assimilative capacity.
Yeah.
Yeah.
And in China, in most of the area, at least where the people live, we've gone well beyond that. So it goes into ecosystem function, it goes into these ecosystem services, and I think a hybrid of some of these technologies plus going out into the watershed is
Yeah.
how we're going to have to move forward.
Yeah. Yeah, we talk about global change, and we typically think about that in terms of climate, but the nutrient issue globally is a global change, and it's a phenomenon of humanity, and it's huge. I mean, so in U.S. we have this big problem in the Gulf of Mexico with a huge hypoxic zone that's caused by nutrients coming down through the Mississippi into the Gulf of Mexico. And a really interesting thing that I don't know if you saw this, Stephen, 2 weeks ago, the city of Des Moines utility, the water utility, sued the farmers upstream, the conservation districts, for upstream. Did you guys see this? I think this is a huge deal in the U.S. because it's going to be the game changer in terms of Clean Water Act. In the U.S., agricultural discharges are exempt, okay, from Clean Water Act, unless you're an animal feeding operation, pigs, cows, in a big confinement. But otherwise, it's exempt. So how this is going to play out in the U.S., I think it's going to be really interesting, Stephen, in terms of getting to the next level on water quality in our country, which is dealing with agricultural runoff, urban runoff, these things that are more what we call non-point source problems. So game changer, right? So I don't know where this all goes. Yeah. So I think there's many places where we could collaborate. I know at Colorado State University, we're looking at things more from systems approaches and models and information systems, and you guys, it sounds like, really deep in the technology. And, to me, that represents some synergies. I mean, because we're not duplicating, we have some chemical engineering and we have some folks in our environmental engineering program that I think, have a lot of the same interests. But in general, I think we're taking different approaches. And again, Stephen, I don't know if you want to comment on that, but it seems like there's some complementary opportunity here.
I agree. I think one of the aspects is the systems and the ecosystem, but also starting with some of the simple hydrologic models. Simple, but the hydrologic modeling perspective, especially in the context of change and how we include a lot of these nutrients and nutrient processes. Because in China, they tend to be at different scales. And
Yeah.
if we have point sources, we still have a lot of non-point.
Yeah.
So I think a lot of synergy. Are there areas where we could test what we're doing here in China, and are there technologies that can be ported back here?
Yeah.
I think that's a good point. At least currently, since China not only just the point pollution problem, but also has the long point pollution problem. Compared to both, I think the urgent things is first control the point pollution issues because more easy identify, so concentrated. So next step would be, I think, move forward. So your experience could be be good for the government or even the scientists to be very useful for them, design for other considerations.
So every industry that we try to regulate in the U.S., going back to the 1970s, always says, no, we can't do that. We can't afford to do it. Right, it's too expensive, you know, so we can't regulate wastewater. We can't regulate industrial process water, coal-fired plants. I mean, just one after another. And part of our Safe Water Act, Safe Drinking Water Act, Clean Water Act, Clean Air Act, there is an economic feasibility issue that always has to be dealt with in the U.S. But I think one by one we've kind of dealt with them. I mean, I think our CO2 discharges are still very high, and we haven't quite gotten that sorted out. But I think it's true. The pathway in the U.S. was first deal with the point sources, then the non-point. I wonder, though, if you guys can't learn something and even jump ahead of that, because what we found is that we cleaned up the point sources and still had impaired water bodies, still had eutrophic lakes because of the non-point sources. And you know, maybe the new thinking is trying to figure out how to deal with this together. And so you don't clean up the point source and you still have the problem. I think the other thing, and going back to Ed Hall's presentation, I thought that was really interesting how what he said that caught my attention was the dominant paradigm is that in large lakes, these aquaculture operations aren't really what drive a lake to eutrophic. And I think they showed that, no, that's not, you know, there is a tipping point in there that even aquaculture facilities can cause a problem. I know in China, I mean, you all are number one. In fact, my understanding is China has more aquaculture than the whole rest of the world combined. I don't know if that's still a true statement or not, but you all are the global leaders in aquaculture. And I think this is, again, U.S. has a lot of aquaculture, particularly in southern U.S., but we're developing some right here. I don't know if you guys know, we have a new saltwater shrimp facility north of town, which is, the interest is now in aquaponics. I don't know if that term means anything to you all, where you basically combine aquaculture for fish with greenhouses that are hydroponically using the water, the fisher, and the nutrients for growing food. And so you can really densify the growing of fish or shrimp or, you know, some sort of aquaculture organism with plant. So there's a big push on that. We haven't figured all the details out. We have big food safety. Somebody mentioned food safety. We also have food safety issues and standards here in the U.S. that make some of these things very difficult using wastewaters. But what Gao mentioned earlier is there's a call right now, and I think it's NSF calling for a U.S.-China. Is it? Yeah. Okay. So it's water, energy, food is what they're really interested in, is how do we bring these things together and solve these problems together. And so do you know anything more about that call for collaboration, Wei?
Well, you know, Alan can read it, right?
Ken Reardon, chemical engineering.
Yeah, I thought, you know, we should get together, but I don't feel, you know, Alan is supportive. He said, you know, that sharing money should be no problem. But the matter here, who will take the lead as CSU?
Right. So as I see it, it's 12.5 million U.S. on the U.S. side, 12.5 million on Chinese side, multiple opportunity or multiple university involvement to work on this. So I think it's a great opportunity for us to, yeah. So something for us to think about. We have a couple of Chinese guests that didn't get to introduce themselves. And I just wonder, you know, it wouldn't be fair to at least let you all, if you're willing, just introduce yourselves, tell people who you are, because you didn't get to speak.
Hello, everyone. My name is Wei Sun. I'm the Dean of the Research Office of our university. And we come here to looking for some opportunities to develop our collaborations. And I hope you can find some research interesting together and develop some collaborations. That's all, and welcome to our university and cooperate with our professors. Thank you.
Thank We appreciate you being here. As I remember from our visit to Hunan, it's a very old, ancient, oldest. You want to say something about it? It's very interesting when you go there.
I can say something about our university. Our Hunan University is one of the oldest university in the world, with about 1,000 years history. Mhm. She lets at the foot of the Yuelu Mountain and at the bank of Xiangjiang River, and very beautiful, one of the most beautiful university in China. And we have about 35,000 students, and about 2,000 faculty. And we have 23 colleges. It's a comprehensive university. Such research as mechanical engineering, electrical engineering, information engineering, and chemical engineering, financial engineering, etc. Are most important in our university, and civil engineering, environmental engineering. Since the pollution of the water resources is very serious nowadays in China, so the research on the water resources sustainable development is very important in our university. So we want to develop some collaboration with you. Thank you.
Thank you, Dr. Sun. So we were told, I think the University of Alexandria in Egypt and Hunan were like two of the oldest universities that were continuous on the planet. So that's pretty impressive, I thought. Let's thank all of our speakers that were here today, please, everybody. Give them a hand. Thank you all. You've traveled far to be here. We know it's hard. The time is off. It's nighttime for you. So sorry about that. That's the way it goes. But thank you for sharing your information. We'll look forward to finding ways that we can work together. Wei Gao, I think we have some work to do to follow up.
We should all, thanks to Dr. Regan also.
Oh, yeah, no. Yeah.
Prepare, coordinate, this wonderful symposium.
Glad to do it. Thank you, Wei Gao. Okay.